So let's look at an example here. We say given A and B, and we'll define those in a second. Show that they're inverses of each other. Okay, so here's my matrix A, and we'll make it be -1, 3, 2, -5, and then 5, 3, and then 2, 1. So you have to go back to what's our definition of an inverse. If two things are inverses of each other, then if I multiply them, what I hope to get is if I multiply them together, I want A times B to be an identity matrix, and I want B times A to be the identity matrix. Okay, so let's make sure that we can multiply these together. So A is a 2 by 2, B is a 2 by 2, so this matches in the middle, so good, I can get it. I'm going to have a 2 by 2 identity. Again, B is a 2 by 2, A is a 2 by 2. They match in the middle, so I'm going to have a 2 by 2 identity matrix. So I can even go ahead and write that out. So I expect to get a 2 by 2 identity. So that means I'm going to have diagonals are 1 and everything else is 0. So diagonals are 1 and everything else is 0. So now let's go ahead and verify this. So I'm going to pull up my calculator and I'm going to go to second matrix. I'm going to plug in my matrices. I need to put them in. I mean, if you want to multiply it by hand, it's probably just as easy, but I'm assuming that nobody but me likes to multiply matrices by hand. And if you feel desperately cheated out of your education because I'm not multiplying them by hand, just let me know and I'll be happy to add a video. I'm not being sarcastic. I really would be happy to add a video multiplying matrices by hand because it does make me extraordinarily happy to do so. But I'm going to go ahead and put in my matrices, 2 by 2, and 5, 3, 2, 1, and back to my home screen. So I want A times B, A times, oops, that's not what I meant, A times B, that's not what I meant at all. Try this again, A times B, there we go. And A times B is, look, that's my identity matrix. What about B times A? You kind of expected this one to be right, didn't you? You kind of expect the next one not to be, huh? Because that's the way math lectures work, is we do a yesy and then we do a nosy. And there you go. So I can see, oops, I didn't mean to do that in that area. I meant to do that there. But you can see that if I multiply A times B and B times A, I get the identity matrix here, and I get the identity matrix here. So I can say, yes, these are inverses of each other. And I can put a smiley face, because I like inverses. Alright, let's try another one. This is going to be your nosy, just so you know. So are these inverses? So I've got A, which is 2, 1, 5, 3. And I've got B, which is 3, 1, -5, 2. And I'm going to go ahead and say what I want is I want A times B to be equal to the identity matrix, and these are the same size, so we know that's going to be the same size. So we want this, like that. All right. So let me stick this in my calculator, and that's not what I meant. I'm going to go here. So I've still got a 2 by 2. So it's 2, 1, 5, 3, like that. And my other one is also a 2 by 2 still, but it's 3, 1, -5, and 2. So now if I multiply these together, clear that out so I don't get confused. If I say, well, A times B, and I hope that that's going to give me the identity, but it's not. Okay, this does not give me the identity even an eensy-beensy little bit. So already I can say that this is not the identity matrix, so they're not inverses of each other. Okay. Now something important I want you to notice is you can't tell by looking. Okay? You cannot tell by looking. You actually have to do the math. So if you're going up here and you'd say, well, look at these two matrices. Is there any way they could possibly be inverses of each other? Well, I mean, they've got kind of the same numbers. Yeah-ish. Yeah, sure, that makes sense. Of course they are. I mean, you just can't do it that way. One mistake that happens a lot is that students will say, okay, let's say I want to find if these are matrices. If I've got 5, 6, 3, and 4. I want to say B is 1/5, 1/6, 1/3, and 1/4. Are these matrices, or are these matrices inverses of each other? And I can tell you right off the bat, the answer is going to be no, because I just made them up, and the chances of making up two matrices that are actually inverses of each other is almost impossible. But I want to go ahead and prove that to you, because when we say the matrices are inverses of each other, it's not really, you just can't tell by looking. It's not that obvious. If it was that obvious, first of all, a lot of mathematicians' lives would be a whole lot easier. And second of all, we would teach this in the course of like a half an hour instead of over an entire course called linear algebra. But I will go ahead and prove it to you, because I do want you to understand that these are not inverses of each other. Here's my 2 by 2 of 1/5. Can I do that? Yes. 1/6. That's not a 6. 1/6. 1/3. 1/4. Now, as an instructor, you can't imagine my terror at the thought that maybe accidentally these are inverses of each other, but if they are, that's quite ridiculous. I don't think they are. So A times B is, yeah, something completely ridiculous and clearly not an identity matrix. So no, not inverses. All right, so you can't just say, oh, I'm just going to make this one up, because you can't ever come up with an inverse of a matrix just by faking it. Now, the next logical question, and completely legitimate question, would be, okay, well, what if I actually wanted to know what that is? Because, I mean, that's a point something or other, but I can't tell what it is. Here's a good way to do it. So you've got your A times B sitting here. I don't know if you ever use a store key. Right here, let me turn on my key presses so you can see what's going on. What I can do is I can click store. So that means I'm going to store the answer I just got, and I want to store it in another matrix. So I can say second matrix. I'm going to store that in C so that I'll have it. And it says, okay, there's C. Now if I want to know what those actual numbers are, I can go over to my matrices list and hit edit and look at C, and there's the actual values. So if I really wanted to know what C was for some particular reason, I could do that by looking at it here. So you can see that these are the same values, 1.3, 0.76, 1 point. You know, you can kind of figure that's about where they were supposed to be. So that's kind of a neat trick in case you're getting these fractional matrices that are going off the edge of your screen.